Hello guys, so in this video we are going to understand RSA with the help of an example, or we are going to see RSA in action via an example. So before we begin with the RSA, let us just quickly revise what is the RSA algorithm. So the RSA algorithm basically begins with two prime numbers p and q. Then we compute something known as modulus, which is n equals to p into q. Then we compute something known as Euler's torsion function, which is phi n equals to p minus 1 into q minus 1. Then we have, then we take and e such that so this is something which we are randomly choosing e is known as public exponent such that e is less than phi n and it is greater than 2. Then we compute something known as d. D is private exponent such that ed is congruent to 1 modulo phi n. I'll explain about this in when we take examples about congruent basically. And once we have e and d identified, then we will compute ciphertext, which is equals to plain text to the power encryption e modulo n. Please note that here it is n, whereas over here it was phi n. Okay, and similarly plain text equals to ciphertext to the power d modulo n. Okay, so this is the RSA algorithm. Now let us take an example. So let us begin with p equals to let me just take a example. P equals to 7 and q equals to 11. So p and q are prime numbers here. Now, so what will be the value of n? N equals to 7 into 11, which is 77. Okay. What will be the value of phi n? Phi n equals to p minus 1 into q minus 1, which is 6 into 10. Then it is 60. Alright, so let us choose an e such that e is less than 60 and it is greater than 2. So let us assume that e is equals to, let me take a value for e. Let us assume e equals to 7. Okay. Now what we want to find out is d. Okay. And we said that ed is 1 modulo congruent to 1 modulo phi n. So let us try to understand what do I mean by this. So if you see what basically translate to is ed modulo phi n is equals to 1 modulo phi n. Alright, so this is what essentially it means. So basically what it means is that if you take this number, which is ed, let me take a different color, yeah, ed, and divide it by phi n, then whatever is the remainder, so this is what the remainder is, right? And 1 modulo phi n. So I'm sorry, here I think I miss a phi. 1 modulo phi n. So in both the cases, the remainder should be equal. So here also you'll get the remainder as r. Okay. Let me expand it a little bit. So ed is basically ed modulo phi n is equals to what? 1 modulo phi n is 1, isn't it? Right? So so what it simply means is if find a number ed such that when you divide ed by phi n, the remainder should be 1. So that is what we want to, that is what this equation means. Now, how do I find the value of d? Okay, in order to find the value of d, let us look at the GCD equation. So let us say we want to find the GCD of e and phi n. By the way, the GCD of e and phi n is 1, right? So let me say that. Okay. So the condition over here is, I forgot to mention this, GCD of e and phi n is should be 1. Okay. So we have to choose an E such that E respects this condition, which is E should be greater than 2 and E should be less than phi n, and also GCD of E and phi n is 1. In our case, we have chosen E to be 7, which is a prime number. So 7 comma, what is the value of phi n? Phi n is 60. So 7 comma 60 is 1. The GCD is 1 there. Okay. Okay, let's resume with our this. So GCD of E and phi n is 1. We know this. Okay, since we know that GCD of A comma B can be written in the form of AX plus BY. So similarly, applying the same over here, GCD of E comma phi n will be written in as EX plus phi n times Y equals to 1. Now let us do this. In equation 1, let us perform modulo an operation on LHS as well as on RHS. So this is basically what I want to do is phi n times y modulo n equals to 1 modulo. Okay, I'm sorry, we wanted to do it with phi n. Okay, let me just write it down as phi n. Okay, so this is phi n and this is phi n. Right, so this essentially becomes EX modulo phi n and plus phi n y modulo phi n equals to 1 modulo phi n. Okay, and this becomes EX modulo phi n and this entire term is 0, right? Because phi n divided by phi n is 0, so that is why that entire term is 0. So this is what 1 modulo phi n, and this is what is EX is concurrent to 1 modulo phi n, and here x is equals to d, right? So this is what it is, right? So leveraging this, we will be able to find the value of d, right? So I just wanted to show you this, like ED is concurrent to 1 modulo phi n is basically ED modulo phi n equals to 1 modulo phi n, and the same thing we have obtained here also, right? This, and then this translates to this. Now how do we find the value of x, which is d? So for that, we know that extended Euclid algorithm can be used in order to find this. Now let me write down all the constructs which I have used here. So p equals to 7, 11. So p equals to 7, q equals to 11, n equals to 77, phi n equals to 60, right? And e we have assumed it to be 7, right? So now let us use the extended Euclid algorithm to find the value of d. So how do we use it? So basically what do we want to find out is GCD of so basically what do we want to find out here is GCD of 60 and 7, right? And once we represent this, we will get, so by the way, the GCD is 1, right? We know that the GCD is 1. Okay, we can also we will also do the maths behind it. So let me just go to the next page and try to write it down. Okay, so we were trying to find the GCD of 7 and 60. So let us find the GCD. 56, right? 4, then 7, 1 times, 4, 3, 4, 1 times, 1, 3, 3 times, and 0. So this is my GCD, right? Okay, this is the GCD. All right, and what do we need? So remember, with the help of extended Euclid algorithm, and if you're not sure what do we mean by extended Euclid algorithm, please refer to my previous video. There I have explained you about the extended Euclid algorithm. So now using extended Euclid algorithm or using division theorem, we can write down 60 as 7 into 8 plus 4, right? 60 is equals to quotient into dividend plus remainder. So that's the division theorem. Similarly, 7 can be written as, this is 7, I'm writing it down, 4 into 1 plus 3. Similarly, 4 can be written as 3 into 1 plus how much? 1. And similarly, 3 can be written as 1 times 3 plus 0. By the way, we have to disregard this equation. Now from here what we can say is 4 is equals to 60 minus 7 into 8. From here what we can write down is 3 equals to 7 minus 4, and from here what we can write down is 1 equals to 4 minus 3. So let us build on this equation. So 1 equals to 4 minus 3. Now 1 equals to, from this equation we know that 3 equals to 7 minus 4. So let's plug that value. 4, 3 equals to 7 minus 4. Okay, so this becomes 4 minus, and this also 4, so 2 times 4 minus 7, right? And we know that from here 4 is equals to, from this equation 4 equals to this 60 minus 7 into 8. So let us plug that. So this simply means 2 into, let us plug the value of 4, 60 minus 7 into 8 minus 7. Alright, so this turns out to be 2 into 60 minus, we want to express it into, so 60 minus, okay, 16 times 7 minus 7. So what we can write down is 1 equals to 2 into 60 minus, okay, minus 17 times 7. All right, so okay, let me scroll. I'm so sorry, it meant to go down. So from here, and all right, so this is the value we have come up. Now we wanted to find the value of D. Okay, so D is what? So remember this equation, Ex is concurrent to 1 modulo phi n, and if whatever is the value of x, and that is the value of D, so private exponent. So basically what I'm trying to say is that the coefficient of E is our private exponent. Okay, so let's see what is the coefficient of, so the value of E, remember that the value of E was what? Let me just scroll up. Okay, so we started with E as E equals to 7. So E is what? So E is 7. So this becomes my value of this. This becomes my value of D. So D is equals to minus 17. Okay. Now D is minus 17. But here we are dealing with positive numbers, right? Remember the entire thing is modulo 77, right? So now if D equals to minus 17, so what is the positive term equivalent to minus 17? Well, the way we find it out is basically what we do is 77 minus 17. 0, 6 minus 1 is 60. So the value of D is 60. Okay. Oh my god. Oh, I'm so sorry. I'm so sorry. Okay, let me just go a bit down. Right, so till here we are good. D is minus 17, and remember we are operating on phi n, not n. I'm so sorry. So we are operating on phi n. So phi n is 60, right? So phi n is 60, because of which D will become 60 minus 17. 60 minus 17 is what? 43. So minus 17 is basically 60 modulo, sorry, 43 modulo 60. So D is 60. Okay. All right. So now, since now we know the values of, so let me just summarize it one more time. E was, okay. So we started with the prime number P7, Q11, and 77, phi n 60, and E we assume it to be 7, and D we have figured out it is 43. Alright, so these things are known. Now let us perform the encryption and decryption. So remember, ciphertext is equals to plain text to the power E modulo n. Here we will be here the modulo operation is with n. So let us assume plain text is 3. Okay, I'm just using it for the sake of simplification. Otherwise, if you take a very large value of plain text, then the exponentiation will be very high, and it would be very difficult for us to come to the ciphertext and then decrypt it. So anyway, so let us assume that the plain text is 3. So ciphertext is equals to basically 3 to the power E. E is what? 7 modulo 77, right? So, well, this is bit easy. 3 to the power 7 is basically, we can say that 3 to the power 4 into 3 to the power 3 modulo 77. So, which is 81 into 27 modulo 77. Now, this is equals to 81 modulo, so sorry, let me just write it down. 81 modulo 77 into 27 modulo 77, and then entire thing modulo 77. Okay, so this is basically 4, right? If you divide 81 by 77, the remainder will be 4, and this is basically 27 modulo 77. So this is equals to, what is this? 4 into 27 is equals to what? 108 modulo 77, and we divide 108 by 77, then the value we obtain is 31. Okay, so the ciphertext is 31. All right. Now let us try to decrypt this ciphertext. So let us decrypt this ciphertext. Now we know that ciphertext is, what was the value of ciphertext? 31. I'm so sorry, 31. So plain text is equals to ciphertext to the power decryption private exponent modulo n, which is 77. So ciphertext is what? 31 to the power d. D is 43. Remember this. D we have obtained as 43 modulo 77. Okay. Now let us try to solve this. Now this is what I was talking about, that the exponentiation will be very high if we take a very high value, a very large numbers. That is why I was dealing with a smaller number such as 3. But you can see for a very smaller number such as 3, the ciphertext is 30. But anyways, let's proceed forward. So we can write down 31 to the power 43 as 31 into 31 31 square to the power 21, right? That is okay. And this is modulo 77. Now let's compute 31 whole square. 31 whole square is basically 961. Okay, 961 to the power 21 modulo 77. Now if you divide 961 by 77, what is the remainder you'll get? The remainder will be 37. Okay, so 37 to the power 21 modulo 77. By the way, I think I'll create a separate video for modulo operations. I'm just using it very straightforwardly, but I hope that is clear. But in case if it is not clear to you, please drop a comment and I'll try to address them. Anyway, so 31, now again the same thing. We can say that this is 37 into 37 to the power 21 modulo 77. So this is what? 31 into 37 into 37 square. I'm so sorry, this is 20, right? 1 I have taken it out. Modulo 77. Okay, so this is what? 31 into 37, and 37 whole square is what? Well, 37 whole square is 1369. 369 to the power, let me write it down, 20 it is, no, oh, okay, here it will be 10, so 10 modulo 77. Okay, now let's do this. So this will be essentially 31 into 37, and if we divide 1369 by 77, what is the remainder? The remainder will be 60. So 60 to the power 10 modulo 77. Now let's do the same thing again. 31, 37, 60 whole square is 3600, and to the power 5, right? We can write it as this, modulo 77. Now this, and 3600, if you divide it by 77, the remainder will be 58. So 58 to the power 5 modulo 77. Now let's do the same thing over here. 31, 37 into 58 into 58 square to square. So I have taken 158 outside, and then this is 4. Okay, 77. Now this is basically 31, 37, 58, and this is what? 58 whole square is 3364 squared modulo 77. This is equals to 31, 37 into 58, and here if you divide 3364 by 77, the remainder is 53. So 53 square modulo 77. Okay, let me go down. Okay, let me draw a little bit straight so that I have enough space. Okay, let me scroll a little bit up. Okay, now this is equals to 31, 37, 58 into 53 whole square is what? Well, 53 whole square is 2809. 2809. Okay, this is 0 modulo 77. Now this is equals to 31, 37, 58, and if you divide 2809 by 77, the remainder is 37. Okay, modulo 77. Now this is what? 31 into 58 into, I'm just taking 37 in one terms, and we know that 37 whole square is 1369. 1369 modulo 77. So 31 into 58, and if you divide 1369 by 77, the remainder is 60. Okay, so this is modulo 77. Now let's do this. 31 into 58 into 60 is what? 3480 modulo 77. Okay, so this is essentially 31, and if we divide 3480 by 77, the remainder is 15 modulo 77, and 31 times 15 is 465 modulo 77. Okay, so if you divide this, you'll get a t is 3. So this is what was our plain text, right? So we started with the plain text as 3. Okay, I know the competition was a bit long. I hope this video makes sense to you. In case if you have any problem, please feel free to drop it as a comment. I'll try to address that. For now, that's all. Thank you very much.